Hey there, everybody. What's happening? Happy New Year. Hope everybody's having a good, safe one. Please share this out. I know I've been saying that a lot lately, but yeah, please share this one out because I don't think a whole lot of people are going to be here because obviously it's 2 o'clock in the morning Eastern, and there's still New Year celebrations going on across the country. So, well, across the world. So I don't expect a whole lot to be here, and that's okay. But we just had the biggest flare of the cycle. Yeah, you can't make this up. It's kind of cool, but at the same time, it's yeah. So we're just gonna roll with it, you know. I'll tell you what I'm gonna do. And again, guys, this just happened just a few hours ago, so I didn't want to not come out here until tomorrow and you know, make everybody wait and all that. That's trying to see if it's updated for that yet. Man, I don't know. See, not Lasco C2, but Seeds. Is it going to show us any of it? It did. Okay. Right here on the end. Notice there's other flares and CMEs happening. So, you know. Oh, thank you. Thank you, Mark. Appreciate that. Hey, John. Good to see everybody. Hope everybody is having a safe one. Please be safe. Don't be stupid and get in a car and not only put yourself at risk, but put everybody else at risk. It just really is not worth it if you're not in a frame to be behind the wheel. You know, that ruins people's lives. Not just yours, but others. So that's my dad advice for today. Now, I want to say something, guys. This is the most powerful flare, and this is exactly what we would expect to see with an X flare, especially an X5. Okay, this was not completely facing us yet. All right. With that being said, this is still going to hit us. We've already had R3 radio blackouts over the Pacific. It wasn't like, it's not going to affect a whole lot of people because of where it hit the X-rays. Okay, it's just be the Pacific Ocean pretty much. So that's what I'll say with that. Thank you, Stephanie. Thank you for being here. Hey, Lord Kisper, good to see you, bud. Good to see you. I just want to say thanks to all the mods and everybody that's here right now. I mean, I get it. This is in the middle of the night. And but I figured if it's going to be in the middle of the night, might as well be New Year's, right? Everybody's still kind of up. But anyway, let's take a deeper look at this real quick with the data that we have. We're still going to... This is going to be one of those things that's going to be a minute before we're going to be able to figure out what exactly is going to be the prediction or the forecast. It's just too early to be able to give you solid what's going on. But I do think, and I'll show you why here in a minute, this is the biggest one of the solar cycle. Okay? There is no doubt about that. It's an X5 flare, guys. So this is not something to not pay attention to. Now, I want to say this too. This is my opinion. No grid down. Okay. Could we see issues? Absolutely. Okay. Are we going to? I can't say that 100% right this second. All I know is what you guys are looking at right here. There's your X5 flare. It's an R3. Got close to an R4. I'm not sure. I think R4 starts at like X7, I believe. Maybe X6. But I'm not really sure. Now, we're just talking about X-rays. That's the burst of X-rays that hits. It's here in 8 minutes. Okay? Notice that geomagnetic activity is extremely low right now. Why? Because we really haven't had a whole lot of anything going on. Now, we did have a CIR that was forecasted to hit. Now, I'm looking at this, and it looks like it possibly could have. And we just didn't get a geomagnetic storm out of it. They were forecasting that. Okay? They were forecasting a G1 storm today. Well, on the 1st, I think. Yeah, like right now. It looks like they might have backed that off. So, who knows? Now, that was from a CIR. What's a CIR? I know you guys are probably asking that right now. It's a co-rotating interaction region. Okay, it's a CIR. And I'm going to show you give you an idea of what that is anyway. This is the NASA. Oh God, that's the first time I was looking at the NASA model. This is that they have already updated for this X flare. That is the X flare you're looking at. So it is going to hit us. The CME involved with this X flare is going to hit us. It is moving fast. Okay, I don't see this thing arriving any longer than 2 days from now. I'm not saying it's like excessive for an X flare, because it's not. This is, again, I have to stress, it's exactly what you would expect to see with an X flare, X5. But it does look as though NASA's model is saying that a good brunt of that's going to hit us. And now I can tell this is the top-down view. Okay, this is a side cut, and this is our orbital line stretched out in a straight line over here on the right. Okay. So what are we looking at here? Well, obviously it's hitting us in all 3 axis views. Okay, so what that's telling me is this model is very confident that this thing's going to hit us. Okay, so can I tell you exactly what's going to happen with that? No, because there's so many other components that we have to analyze to be able to get a good idea exactly what could happen. You know, again, in I guess I would say in a perfect storm scenario, you know, I'm talking like high end, the worst that would happen from this. Yeah, you're going to see some transformer issues, maybe some power outages in places. But that's worst case, okay? Now, if we go to the middle, yeah, we'll see some electrical issues and all that. But we could see the upper end of that. So I want to make everybody aware of that, but I don't want anybody to be afraid, because there's nothing to be afraid of here. Again, if it does knock some power out somewhere, I don't think it's going to be for very long. You know, it takes a heck of a hit to really knock things out for a good amount of time. Okay, but you know, we've seen things not this strong hit us and blow transformers and mess up satellites and all those things. And why is that? Because this isn't the only thing to look at. This is not the only variable. Direction of it is not the only variable. So many people get hung up on that. So let me show you what we should, where you should start. And that's all I'm going to be able to do, is show you where we can start to look. Right? And that's your space weather conditions. All right, these are the data points that we look at first to see if anything's going to happen. All right, and that I'm talking about not really to see when things are going to happen. As they're happening, these things will move. Okay, these things will change. These values will change. All of that. -6. I say it so many times. -6 on the BZ. This is the red. Okay. I'm not going to go into detail what the BZ is. It's a negative polarity. It's the orientation, polarity-wise, of our magnetic field. Okay? And when it's in a negative position, because things are traveling here not only by just the force of the flare in the CME, the eruption, but magnetics is drawing it here. Or it could be deflecting it when it gets here, depending on where our BZ is at. Now, I will say this. In my opinion, on a flare this strong, it's probably not going to matter where the BZ's at as far as if we get into like G1 storm. I don't think we get out of this without seeing a G1. I mean, honestly. And I'm not saying we're going to get a G1. I'm saying we're going to probably get more out of that. So, a flare this strong can overcome that polarity reflection or repulsion or whatever you want to call it, right? So, say we're in negative position, this flare or the CME that's coming at us, or ICME, interplanetary coronal mass ejection. It's just a coronal mass ejection until it leaves the sun. Okay, sometimes they don't leave the corona. They're not able to make it out, fully out of the atmosphere. The sun draws it back. Okay, that's an actual CME. Now, an ICME, it actually makes it out. It's interplanetary. It fires off into space. Okay, so if this thing is let's say a positive as far as polarity, if the majority of the particles are in a positive, then yeah, it's going to, if we're in a negative on our BZ, they're going to couple and it's going to suck it right in. It's like two magnets getting drawn to each other. We have to always keep that in mind, okay? So with that being said, if the opposite happens, right? Say the CME we're going to assume it's a positive, right? It may not be. It could be a negative. But for what I'm talking about right now as an example, if it's a positive and then our BZ's up here in the positive, it's actually repelling. Okay? It's trying to, because positive and positive in magnetics do not want to be nowhere near each other. You know, you can get two simple bar magnets, put it on a table, and you can prove that to yourself. I mean, put positive and positive. We've all done this. Most of us have as kids. It's the same principle. Okay? So that's why the magnetic polarity is so important. Now, I'm looking at this and I'm seeing a phi angle. This is the solar wind. Okay, the phi angle is the polarity of the solar wind. Not the CMEs, but the solar wind. That's a constant. We're always getting hit with solar wind, whether or not there's a coronal hole or not. But we had a coronal hole open up also. Plus, we have the co-rotating interaction area region, if you want to go off of their three-letter. That's a CIR is what they call them, as abbreviated. What that is it is the region in between a faster and a slower section of solar wind. Okay, that region in between. Why is that important? Well, the slower one in the front, the faster one in the back, it pushes particles together and things become dense in between those two streams. Okay? So it's like a snowplow effect that I've talked about 100 times with ICMEs. The same thing happens if you got two separate solar wind streams coming, and that area in between, the one in the front is slow, the one in the back is faster. It's snowplowing particles, and it's building up a dense section of charged particles that's going to hit us. When that hits us, the shock wave of that very much resembles a CME. So, you know, we're not going to see like big time geomagnetic storms from that. But we could see decent geomagnetic conditions from that. Awesome. They spark Aurora like crazy. So, I mean, and that's another thing with this. You guys better, anybody that does Aurora out there likes to go look at it, this is going to be a good chance for you. You know, this is, like I said, just because it's the strongest flare doesn't mean it's the strongest CME or ICME that's going to hit us. Okay? That's not what that means at all. A flare and an ICME are two different things. They most often happen at the same time. Okay? But when a plasma filament, which is not X-ray at all, it's just lifting off and exploding out into space, plasma, charged gas, that's a CME also. Okay? So it has no X-ray with it. It has very little, I should say. Because, you know, when you see the bright little crackles and stuff, most everything we talk about with the sun has a little bit of everything and everything we talk about. But when we talk about flares, we're going to go with X-ray, right? But then we got to switch to the CME, which happens, you know, typically 2 to 3, 4, high-end 5 days to get here. And if it gets here sooner than that, then yeah, it's moving fast, and we're going to get a harder hit. Now, I can tell you right now that this thing is moving pretty quick. Okay? I can't give you a speed, but it leaves, it left the sun right before New Year's UTC time. Okay? About 2100, I think, is what it was. Almost 22. Like, so, it'd be 10 o'clock UTC, PM. Alright? It leaves, and you can see how fast it gets to Earth. If you look at the date up here, it hits on before the second. Or right at the second. Okay? So this thing is, this model's saying it's going to be here in 2 days. And that's quick. Okay? Now, this is just one model. So, you know, I'm not saying that this is going to 100% be whatever. I'm actually looking at this for the first time with you guys. This wasn't updated earlier. So that's why I was kind of shocked to see it. But anyway, so with that being said, this is LASCO C2. Satellite always looking at the sun. It's about 1 million miles closer to the sun than what we are. And it orbits around the sun with us. It takes it 365 days, just like we do, to orbit the sun. So, yeah, that's what's happening there. But it always keeps its eye on the sun. This thing sees a lot of sun divers, sun diving comets. I'll say that because most people don't know exactly what a sun diver is. You guys can conclude yourself, obviously, and you would be correct. I mean, it's a comet that's diving towards the sun. Sometimes they become sun grazers. What that means is it didn't actually get impacted into the sun. It came close, and a lot of those will actually boomerang back out. It'll keep orbiting the sun until finally it does get ate up. Most of the time, the solar wind and everything from the sun will just destroy it before it even gets close. So that's typically what happens. Now, we've been talking about the one comet, the cryovolcanic comet. There's so many things going on with that right now too, that they're not even sure that thing's going to make it. It's, it's in a cycle right now. I think it's, gosh, I can't remember exactly what it was, but every time that, because it's rotating too, okay? That comet is. Every time that part of the comet is facing the sun, it gets hot and it erupts. And I think it was spaceweather.com was reporting on that last week sometime. It's very interesting because it's in a cycle. It's erupting like that consistently. And so with that being said, we can conclude from that it's going to continue to do that. And if it does do that, it's not supposed to be here, I think, until April. And it's supposed to be visible in the daytime sky during the April 8th total solar eclipse. That's one of the biggest, rarest things I've ever heard of. Okay? You're going to be able to go outside and look at a comet that's on the same side of the planet as the sun is, blaring in your face, which you typically wouldn't be able to see it because the sun's light would just wash it out. So when you get the eclipse, it's going to show up in your sky. So, you know what I'm saying? Hey, Tommy, what's up, brother? Good to see you, man. Guys, get over to the lifeboat. Good things happening over there. Drop that link in there, mods, please. Anyway, so this could end up being a fairly decent situation here. I don't call it a situation. I hate using those words because, yeah, we need to be aware of this, but I don't, again, this is not like a complete global grid down issue at all. High latitudes, closer to the poles, could absolutely see some things happen, okay? You could get power outages. You're going to see internet slowdowns, outages. You're probably going to see all kinds of services getting disrupted. That's just what happens. You're probably going to start seeing reports of, we're going to see an uptick in electrical fires globally. That happens, guys. Almost every time we get one of these big flares. And CME's with it. You're going to see an uptick in seismic activity. You're going to see an uptick in everything. The sun is the biggest controller of our weather here on our planet. And everything else about our planet. It influences us more than anything else. And it pains me that but it doesn't get the attention that it deserves. It simply just does not. It's just the truth of it. And that's why I do what I do. It just is. Oh, heck. Tommy, you just celebrated New Year's, 15 minutes ago? Happy New Year's, brother. Hey, Monk, good to see you. Tell Johnny I said Happy New Year's, too. Get over and check out Chase the Heat also. He is the GOAT of eating peppers, guys. Greatest of all times, I'm telling you. Need to get over and check out Chase the Heat. Amazing things, man. I can't do it. Tommy participates over there. Man, I would be, wow. That's all I can say. Tommy is a tincture guy. Anyway, so we got this flare, like I said. We're going to wait, because we did you guys see what happened right here? This is a proton flux increase, okay? That's radiation storm stuff that we talked about. And it happened right after this X flare. So that's another indication that, yes, this is that things are coming in our direction, okay? Because protons are actually, it's mass. It has, it's an atom. So when we're talking about light and things like that, it's different, X-rays. So when we start talking about particles and things like that, that's what you're looking at with the protons. That's radiation. And X-ray are too, but I'm not going to get into all that tonight. I'll just get off on something we don't need to be talking about right now. Okay, so let's go back here real quick, because again, that the triangle flipped too, roughly about that time too. Oh no, it flipped after. Okay. It is interesting that the dropout that we've been seeing every 24 hours happened right when this thing blew off. So we didn't really get like immediate readings from that, but you can still see it here. But as you can see here, the solar wind, the polarity did flip. The density is rising. That's probably from the CIR I just talked about. The co-rotating interaction region. The two solar wind streams, the area between that, it causes a shock wave. Speaking of shock waves, let's go back over here to ISWA. I'm going to go next out of that. And let me show you this thing on SDO. Because this is, it's pretty cool. It really is. So there is your flare. I'm going to zoom in so we can get a better look. Okay. And so what I'm going to do is I'm going to pause that. Man, okay, hold on. Trying to get this thing to where it'll let me grab it. I'll tell you what I could do here. Okay, hold on one second, guys. Sorry. That's better. Okay. So, it happens over here. If you guys see my thumbnail. Alright. Now this sunspot region just crested over. Okay? In other words, it was on the other side of the sun. Now you see how the camera can't handle all that light? So, and again, this was not a impulsive flare either. I wouldn't call this extreme long duration, but I would call this a longer duration flare because it stayed lit up for a few minutes there. Okay, what that means is there's more chance of a CME to be ejected from that, and obviously it was. So as you can see there, this is the 131 angstrom. Again, this is SDO. It is the satellite that stays in the same spot over our planet and rotates with us at 15 degrees an hour around our axis. Okay. But it always keeps its eye on the sun. So it's really close to Earth. Okay? It's orbiting with the other satellites. Roughly. But it stays over the same Eastern Pacific region from Mexico all the way down to South America. Does like a figure 8 pattern. And I've shown this quite a bit. Okay? I'm not going to show it tonight because, yeah, it's not. Okay, so that was the 131 angstrom. Now, if we go ahead and I'm going to go ahead and zoom back out a little bit to make this a little easier on me. What I want to do, I want to show you the shock wave. Now, we had a big coronal hole. See that? Go all the way from the northern polar region all the way to the south. It was completely all the way across. So we are going to get wind from that. We are actually probably getting it right now. And this is part of the reason they were saying we're going to be in in that co-rotating interaction region, CIR. So let's take a look at the shock wave on this, okay? Because this will give us a good idea of if it's going to hit. And I'm not even going to have to say anything to you guys because you're going to see it. Remember, it happens here, and you're going to see the whole atmosphere of the sun just ripple across. So let's do it. Here we go. Right about. See how fast that was? That's what I'm saying. This thing is moving fast. And I'm going to zoom in, so don't worry about that. There's the flare, but do you see how the corona is just like rippled all the way through? It sent a shockwave through the corona of the sun. Okay? And that's exactly what we're seeing there. Okay, so let me back it up. And here it is again. See how it just kind of rippled right through? So, I mean, it definitely is a wham. I mean, and this is what we would expect, guys. I mean, honestly, it is. It's just simply what we would expect to see from an X5 flare. Now, what I do want to say, because it rippled all the way across, you can see how the whole sun gets affected way over here. So, there, in my opinion, there's very, very little chance this is going to miss us at all. We're going to get something from this, is what I'm saying. I can't give you 100% what that's going to be. I can give you an opinion. My opinion is if we get hit like this is showing us, like the NASA tracker was showing us, we're probably looking at a G3, maybe a G4. But again, all those other conditions come into play. And again, that's why I've been telling you guys I'd now cast. I don't try to forecast because it's just too hard for me to do. I know that. But as you can see, it just rippled all the way across there. So let's take a look at the 304 angstrom. And this one, we're going to look at GOES satellite. I'm not going to explain how GOES orbits, but it's roughly the same thing that we see from SDO. Okay? It's just a different satellite with the same kind of equipment on it. They use GOES for a lot of weather here on the planet. Radars, things like that. Okay? You guys have probably heard of GOES 16. That's a satellite. That's exactly what we're looking at here. Now, sometimes they use GOES 18. But this is the 304 angstrom. So what this is going to show us, again, it's actually ionized helium. That's the gas it's looking at. But it just gives us another visual of what's happening. Okay? So if I back this up, see that? Now I know that doesn't look like, oh my gosh, impressive. But let me assure you, when the 304, when you can see a ripple through the atmosphere on the 304 view, it's significant. Okay, the 304 usually just picks up like very highly detailed filament releases and the plasma itself. We don't see a whole lot of the shock wave when looking at this angstrom, but we're able to see it on this one because it was big enough. See that? So, and that's why I'm showing you this, because we don't typically see that with the 304. At least not to this extent. So, yeah. So there's that part of it. Let's go over here to, now this is the 94 angstrom. This one here, it gives us some pretty good views from time to time, but it likes to focus on right where the sunspot itself is. The rest of it is kind of dull when you're looking at it here, and you'll see what I mean here in a second. See how it's even dull just there? It really does highlight where the sunspot groupings are. So there's your flare, and then again, you're not going to see much of the CME on this view. And again, this is the 94 angstrom. We're talking about angstroms of light. Our eyes can only see a very little part of the light spectrum. Okay? And that's why we do this. We put filters on these things, and that's what we see. 171. This is one of the, like, in my opinion, one of the best comprehensive looks. Now, we can look at a composite, too, where they overlay multiple angstroms of light into the same image. I'm not going to do that tonight, but you can do that. And it gives you a pretty good idea also. It takes out some of the detail, but it does give you an idea of what's going on. So if we back here and wham. Okay, so this gives us a different view of the corona too, right? So what I'm going to do is I'm going to back that up, and we're going to see that. See how it ripples across? So you can definitely see how this is at least Earth-facing enough that we're not going to just take a little glancing blow from this. This is going to be something that's going to hit us more, not directly. Now, if this had happened 4 days later, when that sunspot's going to be over here, again, that would be a direct hit from the X5 flare that produced a big CME. And then we would probably be having a different conversation, because it would be harder hit. But I do think this thing's moving fast, and this is exactly what we would expect to see. I mean, it's just crazy. Hey, Mr. Hagen, good to see you. Will we see a solar flare? We just had one. That's what the X5 flare is. A flare is just the X-ray. Okay? And when we're talking about flares and X-ray, when the X-ray gets here, it only takes it 8 minutes. Okay? And that's where the radio blackouts come from. Now, we'll see the other issues when the CME that was produced after the initial burst of X-ray. If anybody's got any questions, pop them in there. I'll try to look at the chat here and let you guys see this. I do look for these things to be updated rather quickly tomorrow. This isn't, they're going to be jumping on this, because this isn't something that, well, like I said, this is the biggest flare of the sun cycle. Okay? So if I back out, give you guys kind of an overall view there. Now, what we can do, I guess, real quick, let's take a look at Soho. And this is the same view I just showed you guys here. Okay? But this is Seeds. This is a different website. So how can I say this? Their data is on more of a delay. Okay? It takes us a little bit longer to update. So if I go to next day, is it going to give us anything? Nope. So if we go back over here to ISFA, where we were just at, we get to see all the way up until we get 6 more hours of data. This thing updates more often. Okay, over here on ISFA. It's the same satellite, it's the same data. Okay? The same imaging. Well, we just get it quicker here. Alright? They're getting the data from the satellite. Okay? So these websites are just different websites. They're not different data. It's all the same data. So let me back that up. Let's go, what do you think, 200 frames? And 15. Okay. So now, again, as we move forward here, I'm going to go ahead and zoom in and give us a better look. And I know people are sorry guys, I took my eyes off the chat again there. All right. And right about there. Yeah. So, yeah, guys, this isn't missing us. This is going to hit, no doubt, in my opinion. But, again, I will now cast this for you guys, okay? I'm not going to come on here and tell you that something's going to 100% happen, because it never does happen that way, guys. It just doesn't. I've been wrong so many times when I thought I was going to be right, and I'm just not going to do that to you or myself. But, so let's back this up so you can see how we get a halo signature, at least a 3/4 halo. What that means is this is an occulter disc. This disc is on the camera itself, the imager. Okay? This white circle is the surface of the sun. This is here to block out a lot of the light from the sun so we can even get an image at all. So when we see the plasma poke its way all the way around this thing, we call that a full halo. Okay? So as I bring this in, there. Okay? Wham. So, yeah. Now, why do I always show you guys this one? Right? Soho? There's a reason. Okay? I do this for a reason. Because this difference image here, it really does give everybody a better idea, especially basic idea, that people, when we don't completely understand the tools that we're looking at. So that's why I use this one, because it's so easy to see. And if they were to update this thing quicker, it would be awesome. But, I mean, I get it. I mean, especially like on the weekend and holidays, these people need to take a break too, guys. So, you think it's just somebody, a computer out here just doing all this? No. There's people out here that have to do this. And that's why I try to remind people of that. So as we move forward there, you see that, I mean, this thing is, it's impressive. Now what I want to say, the size of it's pretty decent size. But for me, what I'm seeing is most impressive right now is like the speed of it. 7.4 earthquake, that just happened. Wouldn't surprise me, because that's what, we're 6 hours past, well, almost 8 hours now, past the time of the flare. And also, let me point this out too. I don't talk about this often because I'm not the earthquake guy. I would send you guys over to Ron Tyler, Emergency Management Associates, and of course all the other big guys to talk about it. The Carrington app. Guys, I've been talking to Todd in the background. Go check out that app. It's awesome. It's got everything I'm showing you right now. Plus, I'm not sure if it sends alerts, but I think it does. I went into the app a lot. I've been using it quite a bit. I'm still getting used to it, so I don't know exactly everything it does yet. But he likes feedback. He's trying to make the app better for everybody. It's called the Carrington app. So go to the Play Store and check it out. I would highly encourage you guys to do it. So that's just my opinion. But when we're talking about the earthquake thing, one thing I can tell you, when we get coronal holes facing us, earthquake activity, always, we see upticks. You can almost count on there being an earthquake watch every time a decent-sized coronal hole is facing us. So you take that along with what's happening right now on the sun. And let me show you this too, because I'm just going to hit start. That is not the only activity that's going on. You see all the other stuff? So things have not stopped. We are in solar maximum, in my opinion. We're not to the peak of it. But again, they're now saying that solar max is going to be this year, 2024. That was not the case 6 months ago. 6 months ago, they were saying 2025. Okay? So solar max is getting here quicker. Hey, Full of Hope, good to see you. 7:35 in Ireland. Top of the morning to you. Love it. Love it, love it, love it. Yes, it triggers earthquakes. Yes, it does. I don't want to say, I hate to use the word trigger, because that right there, when you use the word trigger, it implies like, it's like that thing, right, that one thing caused that, right? there's so many things that are in play when we're talking about earthquake prediction, right? And that's why I don't try to talk about it much, because I simply don't have the knowledge to. You know, I'm still gaining knowledge on space weather. I'll probably never stop. And also, guys, listen, like the James Webb Telescope, it's turning physics on its head. That's just the God's honest truth, especially cosmology. Okay? Yeah, I mean, it's exciting, but every scientist in the world right now is scratching their head on what they're seeing. You know, obviously there's a bunch of theories getting thrown around. What's going on? Well, the satellite can see things way, way further back in time than what we could before with the Hubble. Okay? And what's happening is they're seeing not just one galaxy, we're seeing multiple galaxies now that should not be able to have existed because they got too big too quick. Just saying. Okay, so something is wrong with the cosmology, with the science. And again, most scientists will tell you that's okay because that's exciting. Now we can try to, dive into new stuff. And, it may just be a small tweak on what our science is. It could be how we measure time itself, time and light and all those things. That could be the issue. It could be a whole lot of, without sounding cliche, there's an infinite amount of possibilities that could be what's going on here, right? So, yeah. And you're probably going to get 1,000 different opinions from 1,000 different people. And, and I think that we need to listen to everybody, and I think that we need to pay attention. And let me tell you something. Everybody here that's listening to my voice right now, I promise you, you can understand all of this at a level that at least you can have a decent understanding of what's going on. Nobody expects everybody to have a deep understanding, but most of us just want a basic understanding so we know what, when somebody says something, at least we're not lost in the conversation, right? And so don't be afraid of this. Don't be afraid to ask me questions. I will never think it's a stupid question. I promise. I promise, promise, promise. Hey, Ripper, seen you in there a second ago. Thanks for being here, brother. Happy New Year. Okay, so now again, guys, I guess what we'll do now, let me do this. Let me go over here. And this is NOAA Space Weather Prediction Center. If one of my mods could put the link in here, I would really appreciate it. So if you scroll down to the bottom, you're going to get these dashboards, right? So you can see, like, Space Weather Prediction, Space Weather Enthusiast. That's the page we were just looking at, this one. If you want to know about Aurora, you hit the Aurora, okay? It's going to give you everything about Aurora. So they're saying tomorrow night, this is the Aurora forecast. This is not the CME. This is from the CIR. That's what they're saying. Okay, the CIR is what's going to be causing this. The interaction region in between the two solar wind streams. Okay, it's just like a CME hit. It doesn't typically last very long, but yeah, they can be hard enough to put us into geomagnetic storms. But and this is what I said earlier. Remember I said it was going to cause Aurora? So anybody in these areas need to be looking for Aurora. And this red line shows you how far down. Now what I want to say, and this is important, okay? If you scroll down here, this is what we would expect to see with each level of geomagnetic storm activity. So if you get a KP of 5, that's a G1. Okay? This is the kind of Aurora model that you would be looking at. This is what you would expect to see. A KP of 7, that's a G3. This is what it should look like. KP of 9, that's a G5. Okay? This is what it, according to what their models are showing, This is what their model would look like for Aurora. I found, especially in the past couple years, when we're looking at this, we get to a KP of 5, it's looking closer to what a KP of 7 is. What I'm saying is we're seeing stronger Aurora with a lower level storm now. Why is that happening? A lot of people ask me that. Well, that's because in my opinion, our magnetic field, the reason is our magnetic field is weakening. It's data. It's there. You can't deny it. That's the data. It's roughly about 25%, getting close to 30, weaker than what it used to be. Okay? So you may see them update this. Okay? So it's not going to take as much to get us some really good Aurora. And with that being said, with our magnetic field being weaker, it's not going to take as much to give us good hard hits. Okay? So that's a good statement, Raph. That's so cool. I'm a pagan, and even I understand this is biblical. That's awesome. Oh man, thanks for that. Hey Trinity, good to see you. Ah, you guys are awesome, peeps. By the way, let me welcome Trinity and Rip. They are now 2 of my managing moderators. I've got I don't think Eileen is here, but she's my 3rd. What that means is they can make changes in the chat for me. Like if the chat gets too fast, they can slow it down, those kinds of things. And there's a couple other things that they're able to do. That's just something cool that YouTube has done. So the the channel owner doesn't have to take focus off of what they're talking about. And those guys are gracious enough to take it. And I asked them first, by the way, because sometimes it can be hectic to be a mod. Anybody that's ever been a mod, it's yeah. So happy New Year to everybody. Just saying that. So I'm gonna turn my attention to the chat here for a minute, and if you guys got any questions, fire them in there. You might tag Wages World, say at Wages World, so I can see it. And even if I'm not looking at the chat and you do that, one of my mods most likely will pop it in there when I look at the chat. They'll be like, "Hey, Mark, they asked this question." Okay. So, if you guys got any questions, please ask. I do plan on having, and I've been talking about this for a long time. I want to have, and it's all my fault. Okay. I want to have people on, and I want to do a call-in show and have you guys ask questions. I'm just now starting to get myself to the point where I'm going to be able to do that. There's a whole lot of reasons for that. Okay, guys? I'm not going to get into the reasons. I've had a lot of life happen, just so you know. Big life stuff. Hey, Menacing, good to see you. Thanks, Ripper. Thanks, Trinity. So if you guys got, Japan just got hit, really. Let's go look at that. Okay, guys? You guys want to look at that? You guys hang around here for a second. We'll go look at that. If they just got, I heard it earlier in the chat too. Somebody else was saying it. Let's go to, where is my, oh my goodness gracious, people. USGS, where's it at? There it is. Yeah, they sure did, guys. Wow. Okay. That's not cool. Not cool at all. Oh, wow. Guys, that happened over the water, too. I don't like that. I ain't saying it's a big deal yet. Yeah, look, guys. They're flashing tsunami threat. That happened like a half hour ago. There's something else we can look at too, guys. That's going to ring through the whole planet, just so you know. Anybody doesn't know anything about earthquakes? Hey, Mark J, good to see you. That's what I was getting ready to do, Mark J. You're going to go to the buoys. Yeah, stick around for this, guys. You guys might want to see this. This is what we do when we see... That's interesting, though. Why are... What I don't understand here... The earthquake was here, guys. None of these buoys were going off. That's really strange to me. And again, I don't know enough about this to even have an opinion, to be honest with you. And I'm not going to sit here and try to say that I do. So if we look at where this happened, see how it's on that side of the island? It's on the continent side of the island where that happened. And the buoys that are going off are on the other side. Yeah, that's real, Patrick. Unfortunately, that's what that... Well, it doesn't say warning. Okay? I want to make sure everybody understands this. And this will happen until they look at it. And they're comfortable enough to say, you know, hey, didn't the big one that happened over here in India, wasn't that like Christmas Eve or Christmas Day that year? Wow. But anyway, yeah. Now, I know everybody's going to say, did the flare have anything to do with this? I'm not going to say yes or no. I simply just don't know. I don't know. You know, I do, like I said, we would expect, and again, let me just show you this again. These coronal holes, okay, we expect seismic activity when those things are facing us. When we're connected to that. You know, Ben Davidson, he talks about blot echoes and things like that. And I understand what that is, but I can't teach it, okay? So that's why I don't try. And it ain't that I don't understand it. It's just that I don't feel comfortable enough trying to tell people, hey, this is what's going on with this. It would be very irresponsible for me to do that. That would be suspicious observer for anybody that's wondering. Really, Shinobi? Wow. 3 to 5 meters? Huh. Wow. I mean, I just don't know what to say. But it just is what it is. Really? Earth changes. 6.5 and a 6.3 in Russia. Oh, right. Well, there's some aftershocks in Japan happening right there, too. Let's, there's a 5.3 in China. That happened earlier this morning on the 31st. Now, this could be not updated for that. I don't know. It definitely could be correct. I just don't know. USGS isn't showing it. Not that I can see, but doesn't mean it ain't happening. So yeah, that's very significant. Oh, you lived there. Well, I guess I should have known with the name Shinobi. Sorry. Wow, Mark, my gosh. But yeah, guys, that's wow. Are you anywhere close to the? Oh, look at that, guys. They just updated that. That's red now. That was yellow 2 seconds ago. So this is being felt out a good distance away. You see that? Let's zoom into that. Let me show you this. What I'm looking at here. Looks like it happened over that little peninsula. Underneath that. But close to the water. So I guess if that's actually the case, I mean, I understand why those buoys are going off on the other side of the island. I get it. But, you know, and I guess the seismic activity could have been pushing it that way too. You know, I don't know if they're going to see a slosh back over here or what, but wow. That's all I can say to that. That's a... Let's see here. It says near the coast of Japan. Wow. Okay. And again, guys, I am just not the earthquake guy. Now, let me show you this. I think I can... Let me show you the helioplots. And my guess is you're going to see it ripple across the planet. Okay? This is... And let's go here. Now, let me try to pull this up before I go any further with that. Goodness, where's the helioplots? Go. Private center. Siege. I might have taken that off of my my shortcuts. I must have. Well. No, here it is. Found it. Alright, it's the USGS helioplots. Data not available. Okay. That's Thailand, guys. That's probably just a complete black. That's probably a faulty helioplot. Korea's seeing it vibrate. Let's see if we can't. And if you notice, guys, I want you guys to notice something here. Anything that you're seeing here, it's all happening roughly at the same time, right? So you got to understand that that is, you know, we're looking at Hawaii here. This is Ukraine. So that's from that, most likely from that earthquake. That's Russia. Okay, well, here's the Japan one, guys. So, and these things probably aren't completely updated yet. I don't think this is real time. Whoever said there was earthquakes in Russia is probably right on it, because I'm seeing a lot of the helioplots giving us readings there also. And there's Taiwan. Yeah, so it's all over in that area of the world. I would think Mongolia. I would think, guys, that we're going to see, yeah, I mean, there's no doubt about it. There's Russia again. So there were definitely something going on in Russia too. So, and if you think about location here, let me just go on down. I know it's probably making people sick. Sorry. Doing it that fast. But it all happened at the same time there. You see that? How shallow was it? Anybody know? Let's go look. there. And off of there. It says 10 kilometers, okay? But let me say this, guys. 42 kilometers? Okay. That 10 kilometers, if you guys ever go over here and look, that is a default, okay? Until they know the exact distance, how deep it is, that's what it will say. 10 kilometers is their default. All right? So, again, with that being said, yeah, I mean, I would definitely probably trust menacing muskrat on that one. 7.5, 42 kilometers northeast of Anamizu, Japan. 6.2 miles deep. Guys, that's shallow. If it's 6.2 miles, even 42 kilometers, that's, guys, I'm telling you, that's shallow. Which would most likely cause a bigger tsunami issue. Hey, Shinobi, if you're still in here, are you getting any warnings? I know you said you were listening to the radio, but I would be interested to see 5-meter tsunami observed. Okay. Now, guys, anybody that lives in that area probably already knows. If anybody's listening to me from over there, already knows what to do in these situations. I can't give you good instruction on that other than just pay attention to all this stuff. But I would say this. I would caution against thinking that 5 meters is going to be the end of it. All right? Oftentimes, you'll see one come in, and then a bigger one behind it, and then a bigger one behind that. You got to understand how it works in the ocean to be able to get a good idea how a tsunami actually can threaten everybody. Okay? Yeah. That's crazy. Yeah, I get it. Yep. Jehovah's daughter. For sure. Five, that's where repercussions people need. Okay. Yeah, that's what I said. That's why I don't even try to go deep into what can happen with these tsunamis, because I am just not that knowledgeable on it. I mean, I'm not stupid when it comes to this. I understand what I'm looking at when I'm looking at this, right? Also, I can come over here, and if you guys just want to, if you're not living in that area and you're just trying to get a general idea of what's going on, if you come over here to the USGS and you click on the earthquake itself, you're going to get these boxes. Obviously, that's the tsunami threat tab. You go over here to the yellow, the pager, okay? All these should really be green during no issues, right? If there's colors there, you can click on them and see what this is saying. Now, again, this is just estimates and forecasting, okay? So it was a 7.5, 42 kilometers northeast of Anamizu, Japan. All right? So, this is their forecast of what happens in this area with this kind of a quake. Right now, they're saying there's a 4% chance that 10 to 100 people could pass away, 30% chance 1 to 10, 65% nobody, right? So, obviously, the fatality here, they're saying is kind of low at the moment. Now, economic loss, this is where we start talking about things getting destroyed. With the 5-meter tsunami, I wouldn't think, coastal areas, but in this neck of the woods, they're used to these things. So they're probably already set there to kind of, combat that. Now, you can scroll on down, you can see these. All right, this is where it happened. You can kind of see these circles that they put on here for you. It'll give you, if you look over here, shaking, and it'll tell you how many people were affected by that shaking. Okay? Nothing was extreme, it says, violent, or even severe. Very strong, They're saying 63,000 people. So why do we look at this? Because in higher populated areas, obviously when things like this happen, what do? You know, we want to look at the higher populated areas because that's where the most likelihood of big bad things happening, right? Not that the lower populated areas aren't just as important. It's just that when we're talking about this is kind of what we look at. So, you know, you can scroll up, you can go here. This actually it breaks it down in city. So, I'm not even going to try to pronounce these names, okay? I'm not going to butcher somebody's name, hometown name. But you can see this. 45,000, 43,000 people live there. Now, it's all in the yellow. That's strong shaking. All of these. They're saying 505,000 people felt moderate shaking. And that was just in that city. Okay? So, yeah. That's what I'll say. But yeah, guys, don't be afraid to come over here and click on these things. I said before, I hate looking at things where people are passing away from an event like this. I hate it. And you guys will see this often from me. Like if I come over here and I see that this pager box is red, I'll click on it, show it to you guys, and I move on quickly. Because it truly does bother me. And that's something I have to deal with in my own life. But that's just me, guys. Sorry. So if we go here. Yeah, and let me say this too. We're looking at USGS. We're not going to get many reports of any out of Russia. Okay? Just so you know. It just doesn't happen. We actually have where we can look at a Canadian map. I haven't shown this for a while. Let's see here. Here it is. So, this is the government of Canada. This is their website. Okay? You can scroll down and it'll show you the earthquakes up in here. Now, why am I showing you that? Well, let me show you why. See any earthquakes there? You know, it's like the earthquakes are just going to stop at the border. I'm just saying. It cracks me up. Cracks me up. I have a question. Why do our compasses only read to the north and not to the south? They would read to the south if you're in the southern hemisphere. If you've got the reverse polarity on your magnet. Okay? It all has to do with magnetism. So if your compass is set up for northern hemisphere, it's going to find north. You can set your compass up to recognize southern hemisphere just by simply reversing the polarity. Okay? You know, we talk about our poles. Oh, crap. Hold on one second, guys. I got to plug my computer in. We're going to lose it here. I wasn't planning on being on this long until that earthquake happened. Sorry about that. Hold on one second. Give me 1 second here, guys. Okay. I think I'm good now. There we go. We got her plugged in. All right. So, is there any other questions, guys? I figured, how long we've been on here? I don't even know. Hour and 10. Yeah, we're probably going to have to cut this one, guys. Been on here quite a long time. Believe it or not, guys, YouTube hates it when you go over an hour. Not that I care about that. I do care about it, but not to the extent to where I'll kill a live stream because of it. But I am going to go ahead and probably kick off here, guys. If I get any other updates on this, I'll pop on for a short one. Maybe even just upload a little short or something to give you an update. I will most 100% be here to give you an update, at least on the flare. This is not, man. Wow. I hate earthquake stuff because there's just no way to, even if you give somebody a warning, what are you going to do? You know, not a whole lot you can, I guess. I mean, I know we know what places to go, how to protect yourself and that kind of a thing. But in a big, gigantic one, especially with like tsunamis and things, it's just a whole lot of different things that can happen. And so we'll take another look at this X-flare right here. And then, tell you what, before I do let you guys go here, let's see if I can't give you update that. Let's see if it. Now, I want to show you this too. If you guys scroll down here, you can kind of see. This might give us yeah, it's giving us a couple frames there of just the CME itself. So you can see how that's significant, right? I mean, just saying. There's one more thing we could take a look at. And I've not been showing you guys this because Stereo A hasn't been doing anything. That's part of that CME. That right there should tell you a lot on how fast it's moving, because it was not on this screen very long. It wasn't in this data very long at all. So, yeah, that means it's moving pretty quick. Yeah, and it's not even going to show it on this one. Stereo A, it's lived past its lifetime, guys, and I don't think we're going to get much more from it. I really don't. I think they might be trying to work with it because it's hanging out close to our planet now. It used to sit out. Here, I'll show you. It used to sit out. Okay. Used to sit out here. Used to hang out about right here, even back here. Now, I get a lot of questions. I'm going to go ahead and answer this too, okay? People ask me, why can't we see the back of the sun? We absolutely can see the back of the sun. But the problem is, to get real-time data from that, you're not going to get it. And the reason why is because, guess what? What's between the Earth and the satellite, if there's a satellite back here? The sun. The sun's in the way, guys. That's simple. That's as simple as I can say it. Now, yes, I've had people say, and I even thought this myself, why can't they bounce it off another satellite and then get it to us? Yeah, they can, but you know what happens when that happens? We lose data when that happens. We don't get all the correct data because every time you bounce something off something like that, you're going to lose something. So they just don't. Now they got, what this one here, what is the yellow one? Because you guys can go over here and look at this yourself. And the yellow one is Bepi. That's a satellite hanging out back here. This is Mars. This is Osiris Rex, the black one. It's been out there for a good amount of time. This red box here is Solo, not Soho. It's a different satellite. Here's Stereo A. See that? It used to hang out over here. Okay? Now, I've also been asked, why do they put them in these positions? They put them in what they call Lagrange points. And it's because that's where they can stay best in position without using so much energy to keep them in that position. It all has to do with orbital mechanics and all these kinds of things I'm not going to talk about right now. But when you hear somebody say a Lagrange point, that's what they're talking about. Lagrange point 1, Lagrange point 2. I think the James Webb Telescope is sitting back in Lagrange point L2, which should be back here. It's behind us. And obviously you got 1, 2, 3, and 4. I think there's an L5 also. I couldn't really give you a solid answer on how many Lagrange points we have. But I know we have at least 4. I think it's 5 though. I could Google it, but you guys can Google that too. But this satellite used to hang out over here, and it gave us a side view of the sun. They could see the backside of the sun a little bit. Stereo B was over here. We lost communication with that. They regained it. They say they can't get data from it anymore, or at least good data. I don't know. I'm not even going to talk about that because that's a big another subject that, yeah. Anyway, it's over here. It was over here. So we had stereo B here and stereo A over here for multiple years. We had a complete backside view of the sun, and they were in a position to where they could relay good data back to us quickly. So that's why. Also, they've now gotten pretty good at what they call helioseismology. Yes, that would be an earthquake on the sun. They're able to use that seismic activity to map out what the backside of the sun looks like as far as sunspots and stuff like that. So they technically don't have to have like an eyeball on it. And now it's not as exact or as trusted as a satellite that's being able to observe the backside, but it is something they're able to use, and it's become very accurate. It's getting better every day. But anyway, so let me show you this too. This is our orbital line stretched out in a straight line. When you see it really hit us like that, you know that we're going to take a hit pretty much. Especially if these other two are showing any kind of hit. The one on the left is top down, okay? Sun's in the middle, obviously, Earth's the yellow ball. Here, this is a side cut. This allows us to see north-south orientation. If it could miss us to the north or to the south of Earth. This one's going to give us east-west on the top-down view. Okay? So, and remember, when you're talking about direction on the sun from a CME, you have to pretend you're standing on the sun. So what that does is, it actually will flip what direction east and west is. North-south stays the same, but not east-west. So when I say, hey, we've got a CME going to the east of us, I don't mean to our right. I mean to our left. Okay? That's what that means. And you'll oftentimes hear me just skip the direction altogether and just tell you left or right. Because I don't, I hate spending time continuously explaining that, but I do because it's important that people know that. So when I say the left limb of the sun, I'm saying the left limb of the sun from our view. If I say the east limb of the sun, that's actually it would be to the left also. See what I'm saying, guys? Hope people understand that. Hey, Murph, good to see you. Ain't seen you in a minute. Good to see everybody tonight. Hope everybody's having a good, safe New Year. I really do. But anyway, guys, this is going to hit us. Anything else happens, guys, I will definitely be here to give you an update. So yeah. So with that being said, guys, God bless. Yahusha saves. You can drink this Kool-Aid. Thanks to all my mods and everybody else that showed up. Love y'all. Be safe.